Hello students, welcome to Vyas Certification Kota. In this series of NCERT discussion, we'll continue further with Mathematics class 12th. The chapter that we're dealing with is three-dimensional geometry, and now is the turn of the miscellaneous exercise. Yes. So along with the questions, we'll be seeing the concepts involved in this particular chapter, although we have seen all the ideas and various equations of line and plane in the previous exercises, but let's talk about all the questions over here, which will be very interesting for us. The first question says, show that the line joining the origin to the point this, line joining the origin to the point this is perpendicular to the line determined by the points this and this. Now how do we handle this? So there's the origin, yes, the coordinates will be 0, 0, 0. Then there's a line which is joining this particular point 2, 1, 1, okay. And we're supposed to show that it is perpendicular to some other line determined by the points, let us say, let's call this B, 3, 5, minus 1 and C, 4, 3, minus 1. Okay. How will we determine whether they are perpendicular or not? So what we'll do is we'll find the direction ratios of the two lines and then we'll try to find the angle between them. We have the idea that A1, A2 plus B1, B2 plus C1, C2, if it is equal to 0, then you can say the lines will be perpendicular. So let's find the direction ratios of OA for that matter. Direction ratios of OA would be 2 minus 1, 2, 1 minus 0, 2 minus 0, 1 minus 0, 1 minus 0. That will be this. These will be the direction ratios of OA. What about the direction ratios of BC? It will be 4 minus 3, which is 1. 3 minus 5, which will be minus 2. Minus 1 minus or minus 1 becomes 0. This is what you have. And once you are aware of this, then what you can do is simply find this product. Check the product A1, A2 plus B1, B2 plus C1, C2. What's that? This is 2 minus 2 plus 0, which is equal to 0. Oh, since this A1, A2 plus B1, B2 plus C1, C2 product, sum of product is 0, therefore you can say that OA and BC are perpendicular to each other. That's what we wanted to prove, right? That's a complete proof of this particular question, number 1, as you can see over here. Question number 2 says, if L1, M1, N1 and L2, M2, N2 are the direction cosines of two mutually perpendicular lines, okay, show that the direction cosines of the line perpendicular to both these are, okay, two mutually perpendicular lines, we are already given the direction cosines, and then the direction cosines of the line perpendicular to both of these is being asked. How will we handle this? Let's say B1 cap is this, having direction cosines this, L1, M1, N1 are the direction cosines of this. Similarly, B2 cap, direction cosines will give you unit vector, right? So the components will be L2, M2, N2, okay. And if you want a vector which is perpendicular to both B1 and B2, obviously you'll have to find the cross product of both of them, right? So in case of cross product, we'll be taking a look at the unit vector along the perpendicular N cap will be equal to B1 vector cross B2 vector upon magnitude of B1 vector, magnitude of B2 vector. This is what you'll have, right or not? Yes. And if you see this carefully, this is nothing but B1 vector upon this will be B1 cap cross B2 vector upon this will be B2 cap. This is what you'll have. N cap will be equal to B1 cap cross B2 cap. That's what we are supposed to find, right? And therefore we'll get directly the direction cosines of the line perpendicular. Since this is a unit vector, whatever you will get over here will be the direction cosines, right? So let's try to find B1 cap cross B2 cap is equal to I cap, J cap, K cap and the components L1, M1, N1, L2, M2, N2. And what will you get? This is M1, N2 minus M2, N1, I cap. This is one thing. What about the next? J cap. With J cap you have L1 N2 minus L2 N1 J cap, and with K cap you have L1 M2 minus L2 M1 K cap. This is what you have, right? This is the normal vector, therefore direction cosines of vector perpendicular to B1 cross B2, that is N cap, will be these components M1, M2, m1 minus m2 n1 comma, this minus will be multiplied inside and what you'll get is L2 n1 minus L1 n2. Then you will get L1 m2 minus L2 m1. Direction cosines of this will be this and this. That's what you can see, and that is what we wanted to prove, right? m1 n2 minus m2 n1, n1 l2 minus n1 l2 minus n2 l1, L1 m2 minus L2 m1. That's the complete proof of this particular question number 2 over here. Question number 3 says, find the angle between the lines whose direction ratios are this, right? How will we find the angle between the lines whose direction ratios are given? Simply, if direction ratios are A1, B1, C1 and A2, B2, C2, you can directly find the angle between by get the value of cos theta from dot product, right? A1, A2 plus B1, A2 plus C1, C2 upon under root of A1 square plus B1 square plus C1 square under root of A2 square, B2 square, C2 square, right? So what you'll have is angle between the lines whose direction ratios 1 are A, B, C. Direction ratios 2 are B minus C, C minus A minus B. These are the direction ratios 1 and 2. Therefore, cos theta is equal to what? Cos theta will be this A times B minus C plus B times C minus A plus C times A minus B upon under root of squares of this A square plus B square plus C square, and similarly squares of this B minus C whole square plus dot dot and another term, right? So and so. If you take a look at the numerator, there will be a modulus to get the acute angle first of all, and if you take a look at the numerator, this is AB minus AC, BC minus AB. So AB and AB gets cancelled, plus BC and minus BC plus AC and minus AC will also get cancelled. This is simply coming out to be 0 in the numerator. Yes, if there is a 0 in the numerator, you can say cos theta equal to 0 implies theta will be equal to 90 degree, that is pi by 2. Theta is simply equal to pi by 2. So angle between the lines whose direction ratios are this and this will be pi by 2. That's what you can note over here. Question number 4 says, find the equation of a line parallel to x-axis and passing through the origin. Parallel to the x-axis and passing through the origin. Okay. So in case you need this equation, r vector is equal to a vector plus lambda b vector. This is equation of a line. A vector is any point. Any point is origin over here, right? So this is 0 I cap plus 0 j cap plus 0 k cap. This is what you have. And B vector is a vector along the line, and the person says the line is parallel to the x-axis. Since the line is parallel to the x-axis, this will only have I cap component and no other component, right? J cap component will be 0, K cap component will be 0. That's what you'll have, right? So equation in vector form will be R vector is equal to 0 plus lambda I cap. This is simply lambda I cap. This is what you'll have of a line parallel to the x-axis and passing through the origin. This is what you'll have. This will be the vector equation or the Cartesian equation. The Cartesian equation is interesting. Let's take a look at this. Point is this, so x minus 0 upon something, y minus 0 upon something, z minus 0 upon something, and those will be obtained from the b vector and its components. So x component is 1, y component is 0, z component is 0. This here is my Cartesian equation of the line. This is vector equation, this is a Cartesian equation of that same line, and that's the answer for this question. Question number 5 says, find if the coordinates of the points A, B, C, D be this and this respectively, find the angle between the lines AB and CD. Well, let's take a look at this. Lines AB and CD, okay. So let me mark point A, point B, point C, point D. Okay, point A is 1, 2, 3, point B is 4, 5, 7, point C is minus 4, 3, minus 6, point D is 2, 9, 2. And for finding the angles, I need the direction ratios first of all. So let me find the direction ratios of AB. And what will that be? AB, 4 minus 1, 3, 5 minus 2, 3, 7 minus 3, 4. This is what you'll have. What about the direction ratios of CD? For CD, you'll get 2 minus of minus 4, which is 6, 9 minus 3, which is 6, 2 minus of minus 6, which will become 8. This is what you'll get. And now I can easily find the angle. But if you observe carefully, the direction ratios of AB and direction ratios of CD these are both proportional. Do you observe that? 3 times 2, 3 times 2 and 4 times 2. These are proportional. Okay, since the direction ratios are proportional, implies that AB and CD are parallel, or you can simply say that the angle between AB and CD is equal to 0, that is 0 degree or 0, what you can say, right? In terms of radians you can say 0, or in terms of degrees you can say 0 degree, right? In case if you forgot about checking whether they are proportional, what will you do? You will simply find the angle using cos theta equal to a1 a2 plus b1 b2 plus c1 c2 upon under root of a1 square plus b1 square plus c1 square under root of a2 square plus b2 square plus c2 square. In that case, the value of cos theta that you will get is simply 1. Okay, if you get a value simply 1, then you can easily say that the angle will obviously be 0 degree. That's what you will get, right? Now that is all that is required in this 5th question over here. Question number 6 says, if the lines this and this are perpendicular, find the value of k. If the lines are perpendicular, so for checking whether they are perpendicular, or if given they are perpendicular, we'll simply focus on the direction ratios and the sum of product of a1 a2 plus b1 b2 plus c1 c2, it should be 0, right? But the first and foremost important thing is the line should be in standard form to note the direction ratios from the denominator. Standard form implies that coefficient of x, y and z should be 1, which is there. Here also coefficient of x, y and z are 1, right? So we can directly note the direction ratios of first line will be -3, 2k, 2. The direction ratios of 2 will be 3k, 1, -5. Okay, you have found the two direction ratios, and after that what you will do is, if they are perpendicular, implies a1 a2 plus b1 b2 plus c1 c2 will be 0. What does that tell me? This is -9k plus 2k minus 10 is equal to 0. What does that tell me? -7k equals 10, or k equals -10 upon 7. That's my required answer. Very simple, yes, very simple to find this. K. Question number 7 says, find the vector equation of the line passing through this and perpendicular to the plane this. Okay, perpendicular to this particular plane, and you are supposed to find the equation of a line. Okay, so if this is a plane, then you are aware of the normal vector of this plane. Normal vector is this I cap plus 2 j cap minus 5 k cap. That's something which you are aware of, right? And then you are asked to find the equation of a line which is again perpendicular to this plane and passing through another point. What is that? 1, 2, 3. This point may or may not lie on the plane. We are not sure about that, but we are supposed to find the equation of this line. Two things are required for finding the equation of a line: a point and b vector. If you observe carefully, n vector is perpendicular to the plane, b vector is also perpendicular to the plane. Obviously these will be parallel, and therefore you can say vector along this will be same as n vector, right? Yes, that's what you can say. Therefore equation of line will be r vector is equal to a vector I cap plus 2 j cap plus 3 k cap plus lambda times that b vector, which is I cap plus 2 j cap minus 5 k cap. This is my equation of line in the vector form, or you can write it in the Cartesian form as x minus 1, y minus 2, z minus 3. That's a point 1, 2, 3, and the direction ratios of normal, which is 1, 2 and minus 5. This is the equation in the Cartesian form. This or this is my final answer for this 7th question, as you can see over here. Question number 8 says, find the equation of the plane passing through ABC and parallel to the plane this. Okay, plane which is parallel to this plane. Let's take a look at what will happen in this case. Let's suppose this is one of the planes. This is r vector dot I cap plus j cap plus k cap is equal to 0, and you are supposed to find the equation of another plane which is parallel to this. Okay, can you please observe that if the planes are parallel, the normal will be same for the two planes, right? This is what you'll observe, right? And what is the normal vector for this? This is I cap plus j cap plus k cap. This is r vector dot n vector. This is the normal vector for this particular plane. Okay, if this is the normal vector for this, then the normal vector is same. What else? Equation of plane passing through ABC. Okay, passing through this particular point ABC and having normal vector as this. What will be the equation? So equation of plane passing through a point A vector, let's say r vector minus a vector dot with n vector is equal to 0 is the equation, required equation of plane. And what is that? This is r vector minus a I cap plus b j cap plus c k cap dot product with I cap plus j cap plus k cap is equal to 0. This is what you have, right? That's the equation of plane in vector form, or you can write it in Cartesian form as by replacing simply r vector by x I cap plus y j cap plus z k cap. This becomes x minus a y minus b times 1 plus 1 times y minus b plus again 1 times z minus c, which is equal to 0, and this becomes x plus y plus z is equal to a plus b plus c. This or this are the two forms for the required equation of plane, as you can see over here. Question number 9 says, find the shortest distance between lines this and this. Okay. Shortest distance is not at all difficult. We can always find the shortest distance using a simple idea, the result, which says, okay, this is b1 vector, this is b2 vector, this is some point a1 and this is some point a2, having a1 vector and a2 vector as the position vectors. So the shortest distance will be the component of this a1, a2 along perpendicular of b1 and b2. So shortest distance will be a2 minus a1, this vector dot product with perpendicular vector, which is b1 vector cross b2 vector upon magnitude of b1 cross b2. This is what you need, and you take a modulus at the end since the distance is positive, right? This dot product can be positive or negative, but the distance is positive, so at the end we take a modulus, right? That's what you do. So the important thing to find here is b1 cross b2 first of all. Let's focus on finding b1 cross b2. First, let's identify b1 and b2, a1 and a2. So in the given question, we note that b1 vector is I cap minus 2 j cap plus 2 k cap. b2 vector is this 3 I cap minus 2 j cap minus 2 k cap. Obviously, first thing which you need to observe is that these two lines are not parallel, right? Then only this is applicable. Otherwise, you'll apply concepts related to parallel lines, right? Okay, and what about a1 vector? a1 vector is 6 I cap 2 j cap. We just need a2 minus a1. So you can easily find a2 vector minus a1 vector, which is this minus this. So minus 4 I cap minus 6 I cap will become minus 10 I cap. There's no j cap. This becomes minus 2 j cap, and this is minus k cap minus 2 k cap is minus 3 k cap. That's what you obtain over here. Okay, using this, and once I find b1 cross b2, I can easily find the shortest distance. So b1 vector cross b2 vector will be I cap j cap k cap 1 minus 2 2 3 minus 2 minus 2. This is what you have. Is that okay? Yes. So this is 4 plus 4, 8 I cap. This is what I observe, right? Please note this carefully. Minus 2 becomes 4, and minus of minus 2, this becomes minus 4, and there's extra minus, so it becomes plus 8. And with j cap, you have minus 2, minus 6, which is minus 8, and extra minus becomes plus 8 j cap. With k cap, you have minus 2 and plus 6. 6 minus 2 is 4. Let's take a look again. Yes, 4 k cap. This is what you get, right? b1 cross b2. Therefore, shortest distance will be equal to this dot product with this. First of all, let's do that. So minus 10 into 8 is minus 80. Minus 2 into minus 8 is minus 16, and minus 12. In the denominator, you need the magnitude of this, which is under root of 64 plus 64 plus 16 and a modulus over here. This is what you have. Right? And where does this take me? Let's take a look at this. 80, 108, this is 108. If you remove the modulus, the minus will be taken care of by modulus. What about the denominator? This is 80 and 60, which is 144. In the under root, it will become 12. Okay, and this becomes 9 actually. That's what you'll get. That's the shortest distance, and that's my answer for this question, as you can see over here. Just one important point to note is that if you want a vector which is perpendicular to both b1 and b2, this is the vector which is perpendicular to both b1 and b2, or you could also have taken, by dividing with 4, you can take a parallel vector which is 2i cap plus 2j cap plus k cap. You can take this vector as well and take the dot product of this with this vector, and then you'll get the same answer. Obviously, you'll get the same answer, that is 9. That's the shortest distance for this question. Question number 10 says, find the coordinates of the point where the line through this and this crosses the YZ plane. Now, what is so special about the YZ plane? For the YZ plane, the x coordinate is 0. YZ plane implies any point will be 0 of this particular form, right? Okay, and the person says find the coordinates of the point where the line through this and this. So there's a line on which two particular points are given. Okay, A and B are given. A is 5, 1, 6. B is 3, 4, 1. So what you need is any one point which is already given and the direction ratios of this particular line. Direction ratios can be found with the help of those 2 points, or you can directly write the equation using x minus x1 upon x2 minus x1 idea. Right? So what I'll do is equation of this line will be x minus 3 upon 5 minus 3 is equal to y minus 4 upon 1 minus 4 is equal to z minus 1 upon 6 minus 1. This is what you'll get, right? So 3, 4, 1 is one of the points, 3, 4, 1 and 5, 1, 6 is the other point. This is what you get, or the equation becomes x minus 3 upon 2 is equal to y minus 4 upon minus 3 is equal to z minus 1 upon 5. This is what you get, right? So any point on this particular line, can be found with the help of this. Point on line will be 2 lambda plus 3 comma minus 3 lambda plus 4 comma 5 lambda plus 1. Now what's the important thing over here? The important thing to note is that you are supposed to find a point of this particular form. Point on the YZ plane. When we talk about YZ plane, what you note is that x coordinate is equal to 0. That tells me 2 lambda plus 3 is equal to 0, which tells me lambda will be equal to minus 3 by 2. This is what you note. If you note that lambda is equal to minus 3 by 2, then you can easily find the other 2 coordinates. Therefore, minus 3 lambda plus 4 will be equal to minus 3 into minus 3 is 9 by 2 plus 4. What does that become? 17 by 2. Then you have 5 lambda plus 1, which is minus 15 by 2 plus 1, which is minus 13 by 2. This is what you get. Therefore, required point on the YZ plane will be 0 comma 17 by 2 comma minus 13 by 2. That's my answer for this particular question. As you can see over here, just one important thing, what you could have done is, instead of going in that direction of lambda and all, you could have directly put this x equal to 0 and solve for y and z to give you that particular point over here, and you will directly obtain this, as you can see over here. Is that all? Yes, that's all in this 10th question over here. Question number 11 says, find the coordinates of the point where the line through 5, 1, 6 and 3, 4, 1 crosses the zx planes. Once again, a similar question to the previous one. Zx plane implies the point will have coordinates x, 0, z. Yes, this is what you'll have. And the equation of line can be written in the form x minus x1 upon x2 minus x1 is equal to 5 minus y1 upon y2 minus y1 is equal to z minus z1 upon z2 minus z1. So x minus x1 will be x minus, let's take that point, 3, y minus 4, z minus 1 upon, what do we have? 5 minus 3, which is 2, and 1 minus 4, which is minus 3, 6 minus 1, which is 5. And we can directly use the idea that y is equal to 0. This implies for the given point, x minus 3 by 2 will be equal to 0 minus 4 upon minus 3, which is 4 upon 3, that is z minus 1 upon 5. And now get the values of x and z. Using this I can get the value of x, using this I can get the value of z. This tells me x will be equal to 8 by 3 plus 3, which is 8 and plus 9, 17 by 3. And here what do we have? Z will be equal to 5 for 20 by 3 plus 1, which is 23 by 3. So the required point on the zx plane will be 17 by 3 comma 0 comma 23 by 3. That's the required point on the zx plane, as you can see over here. Question number 12 says, find the coordinates of the point where the line through this and this crosses the plane this. Coordinates of the point where line through this and this crosses this plane this. Okay. So first we'll find the equation of line, then we'll choose any point on that line in terms of lambda and satisfy this plane to get the value of lambda, therefore get the point. So let me write the equation of line. Line is passing through A, 3 minus 4 minus 5, B, 2, 3 minus 3, 1. This is what you have, right? The equation of line will be x minus x1 upon x2 minus x1 and all. So what you'll have is, let's choose any point, x minus 3 upon something, y plus 4 upon something is equal to z plus 5 upon something. And the direction ratios of the line will be this minus this, which is minus 1, minus 3 plus 4 will become plus 1, and 1 plus 5 will become 6. This is what you get, right? Please note this carefully. Yes. And any point on the line can be obtained by this lambda. Point on line will be minus lambda plus 3 comma lambda minus 4 comma 6 lambda minus 5. This is what you'll have, right? Any point on the line will be this. If this point satisfies the plane 2x plus y plus z equals 7, therefore 2 times minus lambda plus 3, what is that? Minus 2 lambda plus 6 plus lambda minus 4 plus 6 lambda minus 5 is equal to 7. This tells me, okay, 6 lambda plus lambda is 7, lambda minus 2 lambda is 5 lambda, 6 minus 4 is 2, minus 5 is minus 3, and that goes over there, that becomes a 10. This tells me lambda will be equal to 2. Therefore, point of intersection of line and plane will be, for lambda is equal to 2, what you get is, this is minus 2 plus 3, which is 1, 2 minus 4, which is minus 2, and 6 times 2 is 12 minus 5, which is 7. That's my required answer for this particular 12th question, as you can see over here. Question 13 says, find the equation of the plane passing through the point this and perpendicular to each of the planes this and this. Equation of plane passing through this particular point. One particular point is given, and the next thing that you need for a plane is the equation of normal. And a normal can be found easily since the plane is perpendicular to each of these two planes. Okay. So let's take a look at this. Over here, what do we have? We have one particular plane in this particular way, let us say, and in case there's another particular plane over here. So this is x plus 2y plus 3z is equal to 5. Then this is 3x plus 3y plus z equals 0. The normal n1 vector will be this I cap plus 2 j cap plus 3 k cap. This other normal vector n2 vector will be equal to 3 I cap plus 3 j cap plus k cap. This is what you'll have. Please note this carefully. Yes, 1, 2 and 3, yes, and 3, 3, 1. These will be the two components, and a plane which is perpendicular to both of these. Perpendicular to both of these planes will have its normal vector perpendicular to n1 vector cross n1 vector and n2 vector. So for the required plane, if you have this as the n vector and this as the point A, which is minus 1, 3 plus 2, this is what you have. The normal vector will be nothing but n1 vector cross n2 vector, can be found with the help of this, right? And what is n1 cross n2? That is I cap, j cap, k cap. You can use this determinant to solve this. The first component are 1, 2, 3. The next is 3, 3, 1. Where does that take me? This is 2 minus 9, which is minus 7 I cap. Then you have 1 minus 9, which is minus 8 j cap. Then you have 3 minus 6, which is minus 3 k cap. Right? Please check that carefully. The j component is 1 minus 9, which is minus 8. This becomes a plus 8. There's an extra minus, right? So this is what you get. This is the n vector. you are already given a point, so the equation of plane will be r vector minus this minus I cap plus 3 j cap plus 2 k cap dot product with the n vector, which is minus 7 I cap plus 8 j cap minus 3 k cap is equal to 0. This is the equation of plane in vector form. Or you can write the equation of plane in Cartesian form by replacing r vector is with x I cap plus y j cap plus z k cap. And what you'll get is x minus of minus 1 will become x plus 1 dot product with this minus 7. Then you have y minus 3 dot product with this 8. Then you have z minus 2 with minus 3 is equal to 0, and this simplifies to, let's take 7x over there, 8y over there, and 3z over there, and what remains is minus 7 minus 24 and plus 6. So minus 24 plus 6 is minus 18, minus 7 will be minus 25 on this side, and let's take it over there, this becomes plus 25. Equals 0. Just a moment, this is equals 0 will also be there. Yes, this equals 0. That's my required answer. This is a vector form, this is a Cartesian form of that required equation of plane. Question number 14 says, if the points this and this be equidistant from the plane this, then find the value of P. Right? The 2 points are equidistant from this particular plane. Let's take a look at this particular plane over here, and idea of distance can be handled very easily if the equation is written in Cartesian form, right? So let's write the equation of plane in the Cartesian form by replacing r vector with x I cap plus y j cap plus z k cap. This becomes 3x 4y minus 12z. And plus 13 is already there. This is equal to 0. Then you are given a point A, you are given another point B, and the distances of these 2 points are given same. This is be equidistant from the 2 point plane. 1 1 P, and this is minus 3 0 1. This is what you have, right? Yes. So if the 2 distances are same, D1 and D2, so D1 will be equal to D2, implies that, let's substitute this particular point, 3 plus 4 minus 12P plus 13. What are we doing over here? Ax1 plus by1 plus cz1 plus d upon under root of a square plus b square plus c square is the distance. So ax1 plus by1 plus cz1 plus d upon under root of a square b square c square, which is 3 square 9 plus 4 square 16 minus 12 square 144. This distance d1 is equal to the distance d2, which is again ax1 will become minus 9, by1 will become 0, and cz1 will become minus 12 plus 13 upon under root of the same expression 9 plus 16 plus 144 modulus. But this here is irrelevant. This denominators will get cancelled. What will you get over here is 13 plus 4 plus 3 is 20 minus 12p, and its modulus is equal to what over here? 13 minus 12 is 1, minus 9 is minus 8, and modulus will give us a 8 over here. This is what you get. And removing the modulus, what you'll get is, so it will tell me 20 minus 12p is equal to plus or minus 8, or you can say that 12p will be equal to 20 minus plus 8. This tells me p is equal to 20 plus 8, which is 28 by 12, or 20 minus 8, which is 12 by 12. This tells me p will be equal to, divide by a factor 4, this is 7 by 3 or 1. That's my required answer for this question number 14, as you can see over here. Question number 15 says, find the equation of the plane passing through the line of intersection of the planes this and parallel to x-axis. Equation of the plane passing through the line of intersection of this planes, okay, and parallel to the x-axis. So line of intersection, if there's a plane passing through the line of intersection of 2 planes, let's suppose this is one plane P1, this is another plane P2, and if you are interested in this line of intersection and you are supposed to find the equation of another plane like this, then this particular plane will have equation P1 plus lambda P2 equals 0. The equation of that new plane will be of this particular form. P1 plus lambda P2 equals 0, right? That's important. First things first. And then we are given another condition to get the value of lambda. So let's write P1 plus lambda P2 first. For that, let me write P1. Is it easier to use the Cartesian form? Yes, it is easier to use the Cartesian form in such cases, although you can use vector form as well. But let me write the equation in Cartesian form. This is x plus y plus z minus 1 equal to 0. P2 is 2x plus 3y minus z plus 4 equals 0. Simply replace r vector with xi cap plus yj cap plus z k cap. That's what you have done. Therefore, P, the new plane P, will have equation P1 plus lambda P2 equals 0, which gives me x plus y plus z minus 1 plus lambda times 2x plus 3y minus z plus 4 equals 0. This is what you have, and this will become 1 plus 2 lambda x plus 1 plus 3 lambda y plus 1 minus lambda z minus 1 plus 4 lambda is equal to 0. This is the equation of this plane. This is the equation of this plane, right? P1 plus lambda P2, which is passing through the line of intersection of P1 and P2. Now the extra condition which is given is the plane is parallel to the x-axis. If the plane is parallel to the x-axis, then you can clearly say that the coefficient of x or the component of n vector along x-axis will be simply 0, right? That's what you can say. So parallel to x-axis, that's one of the ideas dealing with it, or another idea could be that the x-intercept is tending towards infinity, right? X-intercept will be this 4 lambda minus 1 divided by this, and that tends to infinity, or the denominator of that 1 plus 2 lambda tends to 0. So parallel to x-axis simply implies 1 plus 2 lambda will be 0. That's the coefficient of x will be simply 0. That's the important thing. Parallel to x-axis implies this, which tells me lambda will be equal to minus 1 by 2. Therefore, required equation becomes 0x. This becomes 1 minus 3 by 2 y, right? And plus 1 plus 1 by 2 z minus 1 and minus 4 by 2 is equal to 0. This is what you get. And at max, what you need to do is multiply by 2 throughout. Let's multiply by 2 throughout. This becomes 2 minus 3, which is minus y. This becomes 2 plus 1, which is 3z. And this becomes minus 2 minus 4, which is minus 6 equals 0. Multiplying by 2 throughout. Or you can write it as y minus 3z plus 6 equals 0. We need to keep the coefficient of the first term positive generally, so I have written in this particular form. That's the complete solution of this question number 15, as you can see over here. Question number 16 says, if O be the origin and the coordinates of P be 1, 2, minus 3, then find the equation of the plane passing through P and perpendicular to OP. Okay, O the origin and B this particular point. Find the equation of plane passing through P and perpendicular to OP. So we are interested in this kind of a plane which is perpendicular to OP. O is 0, 0, 0 and P is 1, 2, minus 3. And for finding the equation of plane, what do we need? We need a point on the plane which is given. We need the direction ratios of the normal of the plane, which can be found by OP, right? So n vector will be this. You can observe n vector and the direction ratios will be this minus this, or you can take out this minus this also. That's also okay. So that will be nothing but I cap plus 2 j cap minus 3 k cap. The point is already known. So equation of plane will be r vector minus a vector dot with n vector equals 0. This will be the equation of plane. This tells me r vector minus a vector, which is I cap plus 2 j cap minus 3 k cap, and its dot product with this vector n vector, which is I cap plus 2 j cap minus 3 k cap is equal to 0. This is what you have, right? And what else? You can simply convert this equation in the Cartesian form as well by multiplying replacing r vector with xi cap plus yj cap plus z k cap. This becomes x minus 1 into 1 plus y minus 2 into 2 plus z plus 3 into minus 3, which is equal to 0, which implies that x plus y minus 3z, and then there's a minus 9, minus 4, minus 1, which is minus 14, goes on the right hand side, becomes a 14. This or this is my answer. This is a vector form, this is a Cartesian form of the equation of required plane over here. Question number 17 says, find the equation of the plane which contains a line of intersection of the planes this and this. Okay, once again we are talking about family of planes and which is perpendicular to the plane this. So let's take a look at the two planes P1 and P2 first, and then we can talk about the family, that is P1 plus lambda P2. In that form, it is easier if you write the equation of two planes in the Cartesian form. So let's do that. P1, the plane P1 will be x plus 2y plus 3z minus 4 equals 0. P2 will be, simply replace r vector with xi cap plus yj cap plus zk cap, becomes 2x plus y minus z plus 5 is equal to 0. Therefore, family P1 plus lambda P2 equals 0 implies this plus lambda this. So 1 plus 2 lambda x, 2 plus lambda y plus 3 minus lambda z is equal to, or you can say minus 4 plus 5 lambda. Minus 4 plus 5 lambda is equal to 0. This is what you have. This is P1 plus lambda P2 equals 0. This is the required plane, first of all. Required family of planes. Then the extra condition which is given is which is perpendicular to the plane this. Okay, this is perpendicular to r vector dot 5 cap plus 3 j cap minus 6 k cap plus 8 equals 0. If these two are perpendicular, then the direction ratios of normal or the normal are perpendicular. Therefore, a1 a2 plus b1 b2 plus c1 c2. a1 is 1 plus 2 lambda times this. 5 times 1 plus 2 lambda plus 3 times 2 plus lambda minus 6 times 3 minus lambda. This product is equal to 0. And what does that take me? 5 plus 10 lambda plus 6 plus 3 lambda minus 18 plus 6 lambda is equal to 0. What else? 10, 3, 9, 13 plus 6 is 19 lambda, and you have 5 plus 6, 11 minus 18 is 11 minus 18 is minus 7. That goes on the right hand side, this becomes 7. Therefore, lambda is equal to 7 upon 19. This is what you have. We needed this equation of plane. The required equation of plane will therefore become 1 plus 2 lambda. What is that? 1 plus 2 into lambda is 14 upon 19 x. Then you have 2 plus lambda, 2 plus 7 upon 19 y, and then you have plus 3 minus 7 upon 19 z. Then you have minus 4 plus 7 times 5 is 35 upon 19 equals 0. This is what you have, right? Equals 0, that's what you get. And to further simplify this, what we'll do is we'll simply multiply by 19 throughout, and multiplying by 19 plus 14 will become 33x. This will become 19 times 2 is 38 plus 7 is 45 y. Then this is 19 times 3 is 57 minus 7 is 50 z. Then 19 times 4 with a minus. What will that be? Minus 76 plus 35. What is that? 35 and 6 is 41. So minus 41 is equal to 0. That's the required answer for the equation of plane which is perpendicular to this particular plane and passing through the line of intersection of these two planes, right? So that's the required equation. You can take a look at the complete solution over here. That's question number 17 for us. Question number 18 says, find the distance of the point this from the point of intersection of the line this and the plane this. Okay. So distance of one particular point, if this is line, this is plane, they intersect at some point A, and we are supposed to find the distance from some point B. So the target is to find A first of all, and B is given minus 1, minus 5, minus 10 over here. The equation of line is also given. Line is, any point on the line can be written in terms of lambda as 2 plus 3 lambda, comma minus 1 plus 4 lambda, comma 2 plus 2 lambda. Using this equation, I have directly written the point on the line. The equation of plane is x minus y plus z equals 5, right? The person is given the vector form. We can convert it into Cartesian form whenever we want. So can we easily substitute this particular point on this line to give you the value of give you the coordinates of A. So for A, what do we have? 2 plus 3 lambda, then you have 1 minus 4 lambda, then you have 2 plus 2 lambda is equal to 5. That tells me 3 lambda for 5 minus this is lambda, and you have 2 plus 1 plus 2 is 5 equals 5. That tells me lambda is equal to 0. That tells me lambda will be equal to 0. This is what you note, right? Okay, lambda equal to 0, therefore A, the coordinates of A will be 2 minus 1, 2. This is what you have. Implies the distance AB will be equal to what? 2 minus 1 minus 1, 3 square, minus 1 minus 5 is 4 square, and 2 plus 10 is 12 square and the under root. This is 144. 144 and 16 and 9 is 169 in the under root, which is equal to 13. That's my required distance, as you can see over here. Question number 19 says, find the vector equation of the line passing through this and parallel to the planes this and this. Vector equation of the line passing through this particular point. So one particular point is given on the line and parallel to the planes this and this. Okay. If the line is parallel to two given planes, then what can you say about the direction ratios of the line? So if there is one particular plane in this way, there is another particular plane in this way, and a line which is parallel to both of these will actually be perpendicular to the two normals, n1 vector and n2 vector, right? If there is a particular plane and a line is parallel to the plane, then the normal of the plane will be perpendicular to this particular line. That's what you can observe, right? And once you observe that much, then you can easily find the B vector will be n1 vector cross n2 vector, and that's our target. That's the first target for the line. The first target is B vector. The point is already given 1, 2, 3, so we can always use that, right? N1 vector cross N2 vector is I cap, J cap, K cap, and the determinant 1, minus 1, 2, 3, 1, 1. What does that take me? This is minus 1, minus 2, which is minus 3 I cap. Then you have J cap, 1 minus 6, which is minus 5, that becomes a 5 J cap. Then you have 1 plus 3, which is a 4 K cap. This is B vector for us, okay? And there is a point already given on the line. These are the direction ratios of the vector along the line. So equation of line will be R vector is equal to that particular point, which is I cap plus 2 J cap plus 3 K cap plus lambda times B vector, which is minus 3 I cap plus 5 J cap plus 4 K cap. This is in the form of vector equation. The Cartesian equation can be written as x minus 1 upon y minus 2 upon z minus 3 upon, the denominators will be minus 3, 5, 4. That's my required answer for this particular question number 19th, as you can see over here. Question number 28 says, find the vector equation of the line passing through the point this and perpendicular to the two lines this and this, okay? Vector equation of line passing through this particular point. Once again, vector equation of line passing through this particular point and perpendicular to the two given lines. Similar question to the previous one, just that first we want to find the B vector and then we'll write the vector equation of the line only. So N1 vector is, B1 vector perpendicular to two lines, okay? 1, 1, 1, x, y, z coefficients are 1. So B1 vector is 3 minus 16, 7. B2 vector will have 3, 8, minus 5. That's first thing. Vector equation line passing through this particular point. There's a particular point 1, 2, minus 4, and we need the B vector. Not B1 vector, we need the B vector. The B vector will be obtained by taking the cross of B1 and B2. So B vector is B1 cross B2, since it is perpendicular to both of these lines, right? And what does that give me? I cap, J cap, K cap, and you have 3 minus 16, 7. You have 3, 8, minus 5. This will give me B vector. that is 16 times 5 is 80 plus 80 minus 56. 80 minus 56 is 24 I cap. Then you have with j cap you have minus 15 minus 21. 21 36 minus plus 36, this is what you get. And with k cap you have 8 times 3 is 24 and plus 48, which is 72 k cap. Or what you can do is you can take out a factor of 12 common. This will be 2 I cap plus 3 j cap plus 6 k cap. So B vector will be this. Right? This can be taken as a B vector. For equation of line, R vector is equal to A vector, which is I cap plus 2 j cap minus 4 k cap plus lambda times this 2 I cap plus 3 j cap plus 6 k cap. A few things of importance over here. You could have taken this vector as the B vector as well, or you can simply take out that factor common and take this as the B vector. Here the person has only asked the vector equation, so we can leave the answer at this stage. Had the person asked the Cartesian equation, you could have further written it as x minus 1 upon 2 is equal to y minus 2 upon 3 is equal to z plus 4 upon 6. This or this would have been the answer. Right now, this is the only answer that is required in this particular question for vector equation. Question number 21 says, prove that if a plane has the intercepts A, B, C and is at a distance of p units from the origin, then this is equal to this. Okay, plane has the intercepts A, B and C. So equation of plane, what will it look like? If the plane has intercepts A, B and C, then the equation of plane will be x upon A, y upon B, z upon C is equal to 1. Okay, and distance from the origin is equal to P. This implies that distance from the origin, how do you find that? A x1 plus b y1 plus c z1 plus d upon under root of a square plus b square plus c square. That's a formula, right? So instead of x, y, z, we'll substitute 0, 0, 0. So this is 0, 0, 0 minus 1 upon under root of coefficient of x square. What is that? 1 upon a square. Similarly, 1 upon b square, 1 upon c square. This is the distance which is equal to p. That is given to us, right? And can we rearrange this a bit? Yes. This tells me 1 upon under root of this whole expression, 1 upon a square, 1 upon b square, 1 upon c square is equal to p, or you can write it as under root of 1 by a square plus 1 by b square plus 1 by c square is equal to 1 upon p, right? Taking the reciprocals. Squaring will give me 1 upon a square plus 1 upon b square plus 1 upon c square. And this is what we wanted to prove, right? Hence, proved for this particular question over here. As you can see, the complete solution over here. Question number 22 says, distance between the two planes, this and this is, okay, distance between the two planes can be asked if the two planes are parallel, yes. So are these two planes parallel? Let's write 2x plus 3y plus 4z equals 4. The other one is 4x plus 6y plus 8z is equal to 12. This is P1 and P2 actually seems parallel, but the coefficients are not same. We'll have to write the coefficients in similar terms. So what we'll do is we'll divide by 2 throughout. This is 2x plus 3y plus 4z is equal to 6, right? This is what you have. So now this and this have same coefficients for x, y and z. Therefore distance between the two planes will be d1 minus d2, which is 6 minus 4 upon under root of a square, b square, c square, 2 square, 3 square, 4 square and a modulus. This is 2 upon under root of 4, 9, 16, which is 29. That's my correct answer. Yes, the correct answer is option D, as you can see over here. Question number 23 says the planes this and this are, okay, the planes P1, let's note P1, 2x minus y plus 4z equals 5, P2 as 5x minus, this is 2.5, which is 5 by 2, y plus 10z, which is equal to 6. This is what is given, right? And if the planes are parallel, perpendicular, intersect y-axis, passes through this particular point, which of these is correct? So if you can observe carefully, 10, these are not perpendicular, right? Perpendicular is not possible. A1, A2 plus B1, B2 plus even C2 is positive, all positive, right? But parallel, yes, this is 2 into 2, okay, and this is divided by this and this is divided by this. Yes, what you can say is simply that P1 and P1 is parallel to P2. You have simply multiplied the coefficients by 5 by 2. So 5 by 2 into 2 becomes 5, 5 by 2 into this becomes this, and 5 by 2 times this becomes this. And this is not the same because 5 times 5 is 25 by 2 is not equal to 6. So yes, the two planes are parallel. That's what you can observe. That's the correct option B, as you can see over here in this particular question. And with this we come to the conclusion of this particular miscellaneous exercise from the chapter 3-dimensional geometry of class 12th. A very interesting, very important chapter and an equally important exercise from this chapter. Till the next session, all the best.